In this video, we will introduce the different types of analog modulations. In an analog modulation, the information signal, the modulating signal, is printed, is stored in a sinusoidal carrier. So a carrier is very important in the analog modulations. And a sinusoidal carrier, a cosine or a sine in this case, with the notation is a cosine, has three parameters. We have the amplitude of the sinusoid, we have the phase, and we have the frequency in radians per second, omega c, or in hertz, fc. Three parameters, amplitude, phase, frequency. So we have three different types of analog modulations. We have amplitude modulations when the amplitude of the sinusoidal carrier is not constant but is modified according of the modulating signal, according to the information that we want to transmit. In this picture, we have an example of a modulating signal, the information signal. Here we have a sinusoidal carrier with a fixed amplitude, a fixed frequency, and a fixed phase. And here we have an example of an amplitude modulated signal. Now, the amplitude of the carrier is not constant, is modified according to the information that is transmitted. This is a typical example of the waveform for an amplitude modulated signal. Then we have two different variants of angle modulation, and the name is because in this case the phase and the frequency are in the argument of the carrier, are in the angle of this sinusoidal. And we have phase modulations when the phase of the carrier is modified according to the modulating signal, according to the information that we want to transmit. And we have frequency modulation when the instantaneous frequency of this carrier is modified according to the modulating signal, according to the information that we want to transmit. Here we have some examples of the waveforms of this type of modulations, angle modulation. This is the modulating signal, the information in this case. This is the carrier with constant amplitude, frequency, and phase. And in this case, the amplitude of the modulated signal is constant and the information is in the angle. This is a phase modulation. Instead of having crosses at zero that are equispaced, the same distance between consecutive crosses at zero, now this distance is variable because we are modifying the argument of the sinusoidal. And the waveform for a frequency modulation, if we have the same modulating signal, is very similar. We have this waveform, one example here. Constant amplitude and variant distance between the crosses at zero of the transmitted signal. What is varying is the argument of the carrier, and the variation is proportional to the information that we want to transmit. There are two variants of angle modulations, phase modulation and frequency modulation, and there are also several variants of amplitude modulations because in this case what is going to be modified is the amplitude of the carrier. The amplitude will be modified as a function of the modulating signal and will analyze for different variants. The conventional amplitude modulation, that is also known as double sideband modulation with carrier, the double sideband modulation or double sideband without carrier, the single sideband modulation, and the vestigial sideband modulation. These are the most common variants of amplitude modulations, and these modulations, these variants, will be analyzed in this subject. Therefore, in this chapter, we will see 4 variants of amplitude modulations and 2 variants of angle modulations.